Okay, we are now at question 11. This is a linear log question. So we are given a graph of log y against t. Okay, and a straight line graph is obtained, and we have this intercept over here. So if we recall, for any straight line, the general equation is essentially y equals to mx plus c. In this case of this graph, the straight line equation, my y-axis is log y, gradient is unknown, my x-axis is t, my y-intercept in this case is 1.699. So over here, actually, you can see very clearly how do I find what is my express this in this form over here. So we can easily actually obtain the following equation. Okay, if I were to find the gradient first, okay, if given this point over here 1.699, we know that the coordinates is simply 0 comma 1.699. So therefore the gradient m here can be found using the y2 minus y1 of these two coordinates. So over here m is simply 6.699 minus 1.699 divided by 10 minus 0. I will get 502, I'll get half. Okay, so over here we have found the value of m. So very simply we know that therefore log y equals to half t plus 1.699. Okay, so therefore if I were to express the relationship in this form over here, using converting from exponential form from the logarithmic form to the exponential form, y will be simply equals to 10 power half t plus 1.699. Okay, and then in order to express this in this form over here, I just need to separate using my laws of indices. This is simply equals to 10 power 1.699 times 10 power half t. I can write half as 0.5 t. Okay, and I know that 10 power 1.699, if you key this into your calculator, I'll get 50.010 0.5 t. Okay, and this is the answer for part 1. Alright, so quite simply we can obtain these values here based on the information given from the question. And for part 2, hence or otherwise, determine the elapsed time needed for number of bacteria in the culture to reach 800,000. So essentially it's saying I want the number of bacteria y, and I know that y is the number of bacteria. Okay, so therefore the question is saying when y equals to 800,000, find t. Okay, so when y is equal to 800,000, based on the equation that I have 800,000 equals to maybe to be more accurate, I can leave it as 10 power 1.699 10 power 0.5 t. Okay, so over here very simply just solving this equation for t. So therefore 10 power 0.5 t equals to 800,000 divided by 1.699. Okay, therefore to solve for t, remember we use logarithm to bring down unknown powers. So I can do that by taking log on both sides. Log, I can take simply log base 10 equals to log 800,000 over 1.699. Okay, then therefore simply t, I can bring down the 0.5 t. 0.5 t log 10 is simply equals to 1. Is equal to log 800,000 over 1.699. Okay, therefore moving on from here, okay, t is simply equals to 2 times log 800,000 over 1.699. Okay, and you can key this in your calculator and you should get in 3SF 8.41 days. Okay, t is in days, round off to 3SF. Okay, so this is the solution to question 11 part 2. Okay, let's move on. Question 12. Question 12 is a coordinate geometry problem shows a triangle ABC whereby AB is equal to BC, so I can label them AB equals to BC. Point A is and C is given. Point D lies on the x-axis such that ABCD is a kite. So that means, right, if this is a kite, it means that point D lies somewhere maybe here. Remember, in a kite, right, let's draw my imaginary lines for you to visualize better. In the kite, the diagonals are perpendicular. Okay, so let's say point D is somewhere around here. I don't know where is point D. Okay, gradient of BD. So what I can do is that I do not have the coordinates of B or D, but I have the coordinates of A and C. So what I can do is to first find the gradient of AC first. So gradient of AC is simply equals to 6 minus negative 2 over 0 minus negative 2. Gradient of AC will be equals to 8 over 2, which is 4. Therefore, since BD and AC are perpendicular, gradient of BD is simply equals to negative 1 over 4. Okay, this is for part 1. So part 2, hence find the coordinates of point D. So in order to find the coordinates of point D, what I can do first is to find what is the equation of this line first. And since D lies on the x-axis, it is the x-intercept where y is when y is equal to 0. So to find the equation of BD, and this one should be a BD. Okay, so to find the equation of any straight line, I always need one point and one gradient. So over here, along BD, the only point I know I can find is the midpoint of AC, which lies on the line BD. So therefore, midpoint of AC, okay, midpoint of AC is equal to, in this case over here, negative 2 plus 0 over 2, comma, negative 2 plus 6 over 2. Okay, then therefore from here I'll get negative 1, comma, 4, 2. Negative 1, comma 2. Okay, so the midpoint of AC is this point here. I can now find the equation of line BD. Therefore, equation of BD, the line BD, can be found using the general formula y minus 2 over x minus negative 1, which is plus 1, equals to the gradient, which is negative 1 over 4. Okay, y minus 2 equals to negative 1 over 4 minus 1 over 4 over 4x. Y is equal to negative 1 over 4x minus 1 over 4 plus 2, 2 minus 1 over 4, which will give me 7 over 4. Okay, so from here, therefore, to find the coordinates of D, I just need to find when y equals to 0, okay, 1 over 4x is equal to 7 over 4, therefore x equal to 7. So therefore I can conclude that in this case over here, D is simply 7, 0. Okay, and this is for part 2. Okay, part 3, find the area of triangle ACD. So very simply, you can just use your shoelace method since I have found the coordinates of point D to be 7, 0. Area of AC, area of triangle ACD equals to half times 0, 6, negative 2, negative 2, 7, 0, end off with 0, 6 again. Okay, then you can evaluate out over here. This is simply half times you multiply is simply 42 minus away 2, 3, negative 12 minus 14, which is minus negative 12 minus 14. Okay, then you evaluate this on your calculator, you'll get 34 units square. Okay, so this is quite simple. Find the area of triangle ACD. Okay, so now let's move on to question 13. Question 13, the diagram shows a concrete rectangular block whereby AD is 1.2, AB is 0.5 meters, and lifted at an angle of theta. Show that the height is given by this expression here. So when I see this expression here, you need to know that I have cosine theta and sine theta. One common concept that we have learned to obtain trigonometric ratios is to use right angled triangles, which means that I need to identify right angled triangles that can help me obtain the height h. So let's observe very carefully. It is definitely not very easy to find h. We have to find right angled triangles within the diagram. By observation, you can conclude that I can actually form a right angle triangle here. Okay, imagine this is vertical, this is parallel. Okay, and therefore I can see that, and I can also form another right angle triangle over here. Okay, based on this right angle triangle, I know that this is 0.5 as well. This length over here, let me highlight here, in this triangle here, this length is simply this is the opposite over hypotenuse. So over here, let's call them x and y to make it clearer. I call this x and call this y. Okay, because since the height h here is the sum of x plus y. Okay, so by this formulation, you can see that sine theta equals to opposite y over 0.5 h. So therefore, y is simply equals to 0.5 sine theta. Okay, next one, in this right angle triangle over here, how do we find the angles? You see, if I draw, if this line is horizontal, therefore these are parallel lines. This will be theta in this case, and since this angle here is 90 degree, which tells us that this angle here is 90 minus theta. Okay, and since I make this to be vertical and horizontal lines, this is a 90 degree, which tells us that within this triangle, this angle here is theta. Okay, so therefore now I can formulate an equation. I want to find what is the value of this x. I know this 1.2 value here, and if my theta is this angle here, this is my theta, it is my adjacent over hypotenuse in this right angle triangle. So therefore I can form the equation cosine theta equals to x over 1.2, which tells me that x equals to 1.2 cosine theta. Okay, and therefore since h is equal to x plus y, I will have h equals to 1.2 cosine theta plus 0.5 sine theta. Okay, and this is the solution for question 13 part 1. Okay, question 13 part 2. Express h in this form over here. So what I'll do is that simply let 1.2 cosine theta plus 0.5 sine theta, okay, be equals to r cosine theta minus alpha. Okay, then from here, based on my cosine addition formula, r cosine theta cosine alpha plus r sine theta sine alpha. Then I can now formulate the two equations which needs to be seen in order to score the marks for this question. So first equation, by comparison of the first term here and the first term over here, I can see that r cosine alpha equals to 1.2. Next one, comparing this term here and this term over here, I can see that r sine alpha equals to 0.5. Okay, I call this equation 1, equation 2. To get in order to get tangent alpha and to get rid of the r, I take equation 2 divided by equation 1, sine over cosine. I'll get tangent alpha equals to 0.5 over 1.2. Okay, then therefore from here, I can now get my alpha, which is simply tangent inverse, 0.5 over 1.2, which will give me 22, is it in degree? Yes, in degree, 22.620 first in 5SF. Okay, and r can be obtained using square root 1.2 square plus 0.5 square, which will give me 1.2 square plus 0.5 square 1.3. Okay, so very simply over here, I can therefore conclude, therefore, H is equal to R, which is 1.3 cosine theta minus away alpha to 1 dp, 22.6 degrees. And this is the answer for part 2. Okay, and the last one, part 3, when A reaches the maximum height from the ground, the block will topple over, find the max height. So from here, max height simply is the amplitude of this function. Max height is simply equals to 1.3 meters. Okay, and the corresponding value of theta, okay, it occurs when this angle here in a cosine function, the maximum value, if you recall again, maybe I'll do a simple drawing over here. Okay, so let's look at question 14 now. Solve the equation e power x goes to 6 minus 5 e power negative x. What we notice over here is that to solve equation, it means I want to find the value of x. So over here, it means that we have to kind of try to isolate this e power x. So what I can do is that, first step, to turn this negative power into a positive power, e power x equals to 6 minus away. 5 power times e power negative x can be rewritten as 5 over e power x. Okay, then from here, I can actually, to get rid of this fraction, I can multiply the whole equation by e power x. On the left side, I'll get e power 2x by the laws of indices. E power x times e power x is equal to e power 2x equals to 6 e power x minus 5. Okay, then to solve this equation, I can shift them all to, let's say, the left hand side. So over here, e power 2x minus 6 e power x plus 5 equals to 0. Then to make it easier, I can simply use a very simple substitution. But for those of you who can see how to solve this from here, you can continue moving forward. Let u equals to e power x. Therefore, I will have u squared minus 6u plus 5 equals to 0. Once I've done that, I'll get a simple quadratic equation in terms of u. What I just need to do from here is to simply solve this equation by factorization. So therefore, u minus 5 and u minus 1 equals to 0. Therefore, u equals to 1 or u equals to 5, which gives me e power x equals to 1 or e power x equals to 5. When e power x is equal to 1, therefore x is simply equals to 0. When e power x is equal to 5, to solve this, we take ln on both sides. X is simply equals to ln 5. Yep, and there we have it, the solution for this equation. Then what you just need to do now is to just sub back into the equation to check whether this solution satisfies the original equation. Because if not, you will have to reject the solutions. Okay. So that is the solution for question 14 part A. Okay, so now let's look at question 14 part B. Solve this equation. I have 3 different bases for this equation: log base 2, log base 16, and log base x. One very simple way is to simply make them all the same base. So I think an easier way is that usually we want to make the base a number, and the easiest number we can use is simply base 2. So let's change the base. Log base 2x minus away 3 times log base 2x over log base 216 equals to log base 22 over log base 2x. Okay, then from here, we continue solving. I will get, maybe I simplify this first. Log base 216. So this will give me log base 2x minus away. Log base 216 is simply 4. So this will be 3 over 4 log base 2x equals to, log base 2 is 1, and log base 2x. Okay, then from here you can see log base 2x minus away 3 over 4 log base 2x. Notice that you can simply simplify this very easily. I will get, it's just the same as, for example, 1x minus away 3 over 4x. Okay, so therefore I will have 1/4 log base 2x equals to, let me rewrite this, let me write this clearer. 1/4 log base 2x equals to 1 over log base 2x. Therefore, if I do it step by step, I multiply 4 to both sides to get rid of this 1/4 here. I'll get log base 2x equals to 4 over log base 2x. I cross multiply to get rid of the fraction. Log base 2x, the whole thing square, is equal to 4, which tells me that, therefore, log base 2x is equal to plus minus 2. Okay, and therefore we can solve from here. When log base 2x is equal to 2, therefore x is equal to 2 square, which is equal to 4. When log base 2x is equal to negative 2, x is simply equals to the base power negative 2, which will give me 1 over 4. And with that, I just need to check back. Yes, so therefore I will get the solutions, these two sets of solution that will satisfy this original equation over here. Okay, so this is the solution for part B. Okay, let's move on. Next part, question 15 part I. Write down the first 3 terms in the expansion of this over here. Okay, so maybe to make it clear, let me take a screenshot of the binomial theorem. Here. Okay, so this is the binomial expansion which you will need to refer to in the exam. Okay. Okay. Okay, so let me just place the binomial theorem here. Okay. Okay, so right, from here now we just need to find the first 3 terms. Based on the binomial expansion, we know that in this expansion here, you need to identify what is your a and b and your n. In this case over here, a is equal to x, b equals to 2 over x, and your n is equal to 9. So therefore, in this expansion, x plus 2 over x, the whole thing power 9, is simply equals to, I want to find the first 3 terms. So this will be x power 9, okay, plus 9 choose 1, x power 8 times 2 over x, plus 9 choose 2, x power 7 times 2 over x power 2, plus dot dot dot. Okay, I have the first 3 terms already, so I just simplify from here. Equals to x power 9 plus 9 choose 1 is 9, 9 times x power 8 times 2 over x, then 9 choose 2, 9 choose 2 is 36, x power 7 times, this I square 2 over x will be 4 over x square, plus dot dot dot. So if I simplify everything from here, I'll have x power 9, 9 times 2 I have 18, x power 8 divided by x is x power 7, plus 36 times 4 is 144, x power 5 plus dot dot dot. Okay, so this is the solution to part I. Next part. Okay, now for part 2, to analyze why this expansion doesn't have a constant term. Usually when we see questions that want you to analyze certain terms, singular terms, what we'll do is to analyze the general formula to determine this. So over here, we know that from the binomial expansion, the general formula is located here. So let's use the general formula to help us solve this question. We know that the general formula is for any general term, it is Tn equals to n choose r, a power n minus r, b power r. So therefore, over here I have 9 choose r times x power 9 minus r times 2 over x power r. Okay, so in this case, if I simplify, in order to understand constant term, we know that constant term refers to terms whereby the power of x is 0. So let's collate the powers of x over here to see how we can analyze from the general term. X power 9 minus r. 2 over x can be written as 2 times x power negative 1 power r. Therefore, if I simplify this, I have 9 choose r times x power 9 minus r times 2 power r times x power negative r by a loss of indices. Therefore, this will give me 9 choose r times 2 power r times x power 9 minus 2r. So therefore, to explain why, we can say that let 9 minus 2r to be equal to 0. I want the power of x to be equal to 0. I will see that 2r is equal to 9, and therefore r equals to 4.5. Okay, and we know that r means position, and this r must be an integer. So therefore, since r is not an integer in this case, therefore there is no constant term. Okay, therefore there is no constant term, and that's the conclusion we can get from this. Okay, next one. Find the term independent of x in the expansion of 1 minus 5x times x plus 2 over x, the whole thing power 9. So over here, in order to find the expansion, the term independent of x, okay, so we know that 1 minus 5x multiplied to this entire expansion is simply, using a general term, it is 9 choose r times 2 power r times x power 9 minus 2r plus dot dot dot. Okay, so therefore I know that in order to get a term independent of x, I need to find this one need to multiply to a constant term, and we have learned from the previous part 2 is that there is no constant term. So therefore, no matter 1 multiplied to whichever number here, it will not generate a term independent of x. So all I need to do is to find the term. Negative 5x need to multiply to a certain term here that will give me a term that is x power 0, which means that if this is x power 1, I need to find, x power negative 1 term. Okay, so over here, since I know that the general term formula, the power of x is given by 9 minus 2r, I let 9 minus 2r to be equals to 1. Then from here, I know that 2r is equal to 8, r equals to 4. It means that the term in the fourth position will have an x power negative 1. So therefore, this is the fifth term. 9 choose 4, 2 power 4 times x power 9 minus 8, which is 9 minus 8, which is this one should be let 9 minus 12 equals to negative 1. Then this will be 5 instead. 10, this will be 5, so your r should be 5, which means it's the fifth term instead. Okay, so sixth term, r equals to 5, 2 power 5, 9 minus 10. Yep. Then from here, you can use your calculator to evaluate. 9 choose 5 times 2 power 5. This will give me 4032 x power negative 1. So therefore, in conclusion, in order to find the term independent of x, I just need to multiply. From here, I just need to multiply term independent of x is simply negative 5x times 4032 x power negative 1. Okay, and therefore from here I can get my final answer, which is equal to 20160. Okay, and with that, that is the solution to this part of the this part 3. Okay, moving on. The last question, question 16. Without the use of a calculator, find the exact value of sine negative 75 degrees we know that sine negative 75 degrees is simply equals to negative sine 75 degrees. So without a use for a calculator is a very special hint to tell you that you need to use exact values. And you know that the special angles that you have learned before, special angles are 30 degrees, 45 degrees, and 60 degrees. So if you observe 75 degree, two numbers that make up 75 is 30 and 45. So this can be rewritten as negative sine 30 degree plus 45 degree. Okay, then from there you just need to apply your addition formula to expand out this thing using your addition formula, and then you should be able to get the exact value. So I won't go through this part. This is very straightforward. Okay, for 16 part B, solve the equation here. What you just need to realize is that this is a special identity, 2 cosine square x minus pi over 8 minus 1. You notice that this angle here is half of this angle. Okay, so therefore, if you recall your special identity, 2 cosine square a minus 1 is equal to cosine 2a. So therefore, from here, I can therefore generate that this is equivalent to cosine 2 times x minus pi over 8. Okay, maybe I should use a square bracket instead. Okay, a square bracket instead. Okay, and d equals to sine 2x minus pi over 4. So therefore, from here, you can see that cosine, this is cosine 2x minus pi over 4 equals to sine 2x minus pi over 4. So by observation, you can see that I have a sine and cosine, the angles are now the same. I can divide both sides by cosine in order to get a tangent. So therefore, tangent 2x minus pi over 4 is equal to 1. Okay, let me write the working step down. You divide both sides by cosine 2x minus pi over 4. Then I switch the side. Okay, divide by cosine 2x minus pi over 4. Okay, then from here it's very simple already. So first step, find your reference angle. Reference angle alpha. Tangent inverse 1. Okay, so this question is in radian. So tangent inverse 1, in degree is 45 degree. In radian, it is simply pi over 4. Okay, and we know that from here, 1 is in the first and third quadrant. Okay, so therefore over here we can see that in this case, 2x minus pi over 4. Okay, but note that your range need to update. So over here, this is the initial range given. Okay, let me update the range. Okay, 2x is 2 pi. Therefore, negative pi over 4, 2x minus pi over 4 less than 2 pi minus, 2 pi minus pi over 4, which will give me 7 pi over 4. Okay, so now that I've updated my range, it is much easier for me to now find out how do I calculate this. Okay, so I have identified that the terms are in your first and third quadrant. So therefore, since it is in the first and third quadrant, you can now solve for the angles. We know that first quadrant, your angle is simply equals to pi over 4. Okay, in the third quadrant, you know that your angle is simply 5 pi, or third quadrant is pi plus reference angle, pi plus pi over 4, which is equal to 5 pi over 4. Okay, so therefore over here, 2x is simply equals to 0, comma, simplify will be 3 pi over 2. Therefore, x will be simply it's not 0, pi over 2. Okay, so if I simplify further, x will be equals to pi over 4 comma 3 pi over 4. Yep, and that is the solution to question 16 part B. Okay? Yep, and with that we have come to the end of the paper.